We're at a coffee point house.
Did you see it?
Yeah, I did.
Oh, you see like 3 messages.
Oh, no,
Is it Travis?
No.
I saw like
Wait, how do you spell? No, I did not know that. No.
Oh,
The first one was like the most wait like 4 to 8 years.
it's so
Yeah, wait.
the first part.
like 2 years after that.
Oh, I lost all my.
Yeah. This time we were listening to that. Okay.
Where's Ryan? So we have to talk to him. We're here on, take the first one. Megan. Cammy. Elle. Jelly. Wow, I smell something. Not, it's not vital oxide. What is it?
I hope you like it for you.
Yeah. Did you spray something? Is that what it is? It smells good though. You guys smell that one? Yeah, smell that.
Oh, I got
Maybe a floral.
Yeah, Rebecca, I got the,
Yeah.
I wanted that.
Colin.
That's the one you do.
Yeah.
That's what I thought I would do.
Do it right now.
Oh.
Yeah, surprisingly. I just think I wrote it differently than I did on homework.
Oh, really?
I was worried that I wouldn't remember the echo of the talent, but then I pulled it out of my brain. And it worked out.
Yeah.
I had a notebook for this class. I wrote all of it. This is my second notebook this year already. The first one was only 1 month ago. Oh, yeah. This is
Okay, so these were pretty good for the most part. Honestly, I don't even know that I think they were so good that I don't know that I really need to work them all out. Oops. Hi. Does anybody have a question about one in particular? I felt like most of the mistakes that you made, you're going to know what you did as soon as you see it. At least that's kind of what I remember when I was grading.
We'll do the LNX squared one.
LNX squared. Now, you know we did that one in class, actually. So there's two ways that you could do that. I chose to do it this way. Okay, you gotta understand that ln of x, that's all of that squared, not natural log of x squared. Okay. So u times v minus the integral of v du. So then this is going to all basically just end up being 2 natural log of x. And so you either have to know the antiderivative of natural log, or you have to do it by parts. It's much easier if you just have it memorized. I think it's much easier. If you split it up into u as natural log and dv as natural log, then you have to anti-differentiate natural log earlier, and it's a little bit messier. Still very doable, but it's just a little bit messier. This is screwed. I mean, I thought these were really pretty good. I mean, honestly, I was very, very pleased. Well done, my friends. Well done. On my eye. Oh, gosh. You ever have that, like, on your contacts? Like, it's just, like, not causing any water. It just, you feel something on there. How are we doing? Everybody have a nice weekend and enjoy the Super Bowl?
I was happy.
You were happy?
Because Kansas lost.
You don't like Kansas?
No, they should have lost to the Browns weeks ago.
Yeah, I kind of was hoping the Browns would have won that game, actually. But yeah, I don't know. Tom Brady. They should just name that trophy the Tom Brady trophy. He's like won 13% of the Super Bowls. I mean, since they started. Crazy. It's like 7 out of 55. Crazy. And he's been in like 11 out of 55. Almost 20% of the Super Bowls he's been in. All right. We'll talk about some powers and trigs. No? Don't see why not. Anybody got any better ideas? Stuff we can talk about?
We could play bingo.
Bingo? I don't have any bingo cards. I need one of those like big machines with the balls that bubbling around. And those big stampers. You know what I'm talking about? I used to go there with my grandma to the bingo hall. All those old ladies. They have their troll dolls. Oh gosh. Maddie, what's up?
Are we supposed to know the double angle formula?
Are you supposed to know the double angle formulas? You mean like, are you supposed to know that sine of 2x equals 2 sine x cosine x? And are you supposed to know that cosine of 2x equals 2 cosine squared minus 1, or it equals 1 minus 2 sine squared, or it equals cosine squared minus sine squared? Well, it'd be nice if you knew those. Like, it's certainly helpful. Did you learn those ever?
I remember.
Should I go ask Mr. Craig? Because if that's the case, we need to fix that. Now, can we blame that on COVID? Were you learning trig identities during during March and April.
I don't remember.
Right before, not that.
You didn't do the double angles. What about in the block? You block stars.
I don't remember. He like had a sheet with them on it, but I don't remember.
Didn't you prove identities? Yeah.
Yeah.
We did like the sine squared plus cosine squared in those. So I feel like I know.
Did you do sine, cosine, cosine, sine, cosine, cosine?
Sine, sine, yeah.
Yeah.
So if you did that, you probably did those.
I don't remember.
Because those sine, cosine, cosine, sine, cosine, cosine, sine, sine comes from, or that's the identity for cosine or sine of a plus b, sine of a sum. So it's sine a, cosine b, cosine a, sine b. Does that sound familiar? So if you treat 2x as sine of x plus x, and then use sine, cosine, cosine, sine, that's how you get that. So chances are you did those. It certainly will make your life a lot easier if you know those. Particularly when you're particularly when you're integrating sine squared and cosine squared. That, I mean, I don't know.
It's like we're gonna have a test with this on it.
I'm not gonna have a test where you just fill in the blank and know those identities. It's just whether or not you have them available to you. You know what I mean?
Is there a way to do them without doing
Like sine squared.
that? Yeah.
You can do sine squared by parts. I think we did this at the end of the period on Friday, didn't we?
Yeah.
Like if you do sine squared, but one way of doing sine squared is just replace it with, solve this right here for sine squared. And we did that on Friday, solve that for sine squared. The other way to do that is to do this by parts. U is sine of x. dv is sine of x. So du is cosine. And v is negative cosine. Right? So you have u times v minus the integral of v du. And then change this to a plus. And now change that this cosine squared to 1 minus sine squared. And then this is still equal to sine squared. So the integral of sine squared is equal to negative sine x cosine x plus x minus the integral of sine squared of x. Bring this to the other side. And then divide by 2. And that's equivalent to the answer that you get when you use this identity. What's the answer that we got when we use the identity? What's the answer that you got when we use the identity for sine squared? Go back and look.
So it was 1/2 times x minus sine 2x over 2.
Apparently that is equivalent to this. Well, let's go ahead and divide by 2. That right there is equivalent to this. How? Well, sine of 2x is equal to 2 sine x cosine x. And now those 2's cancel. And you're left with that. If you memorize the antiderivative of sine squared and the antiderivative of cosine squared, you can use it. Like if I were to give you that integral and you just gave me the answer, that's totally fine. In fact, the answer to the antiderivative of sine squared and the antiderivative of cosine squared, they're the exact same, except for one small difference. This is a positive instead of a negative. Like they're the exact same antiderivative, except that. So if you want to memorize it, go for it.
Wait, what's the negative instead of positive?
So the antiderivative of cosine squared is the exact same as the antiderivative of sine squared, except it's x plus. Instead of x minus. Other questions that you want to work, problems you want to work out? You didn't get from the homework? There were some tough ones, there were some easier ones, there were some tougher ones. There's a mix. Annie, what do you got?
Can you do 89?
89. Tell me what it is, friend.
Tangent squared x, secant x.
Tangent squared times secant. Boy, look at that, how it's not erasing. Can't have that. Oh. What number did you say, 89? So what was the trouble that you ran into?
Well, I was thinking of like changing like the tangent squared x to like secant squared x minus 1, but then like there wasn't the derivative, and then I got confused.
So this ends up being the integral of secant cubed minus secant, right? And so you were like, I want to avoid that. And why did you want to avoid that?
Because I don't know the antiderivative of secant.
You don't know the antiderivative of secant? Yeah, you do. It's the natural log of secant plus tangent. Didn't we do that? It's been a while, yeah. I think we did it actually before. We might have done it when we were still virtual. Or it was the first week of that. It involves a clever form of 1. So you know the antiderivative of secant, Annie, but I don't know if you know the antiderivative of secant cubed. Okay? So this is sort of a roadblock right now. Let's try one other thing first. Could you borrow? Could you say that's tangent of x times secant of x tangent of x? Is that true? Okay. So we have two options here. Clearly, this is not going to be a u sub just by changing, right? Because we don't have the du that we need. So we can either choose to try to integrate this by parts, or we can try to integrate this by parts. You think this one? Okay, then let's try it. I'm not even sure this is going to work. We might have to go back and do the other one. Now, I feel like there's an obvious choice for dv here. What's dv going to be? Secant x tangent x. So then use tangent. So what's v here? Secant. And then what's du? Secant squared. Okay, so I have u times v minus the integral of v du. Ooh. Dang. Yeah.
So I got to there too, and what I did, I split it up into secant squared and secant x,
Oh, so you kept going.
and then did another.
Okay. So, but do you see either way that we do this? This integral of secant cubed is staring at us in the face. Okay. Now it turns out the integral of secant cubed is actually worked out in the book. They work it out in the book. But this is a kind of a heavier integration by parts and problem secant cubed is. So let's do it. I think what I'm going to do is just to give myself some more room to work it out. Is I'm going to work it out over here. I'm going to leave this here, but I'm going to work out secant cubed over here just so I have more room, and then I'll stick it over there. Right? So Maddie says she split that into parts. And what did you say? U is
secant x.
and dv is secant squared. So du is secant x tangent x. And what's v? Tangent. So we have u times a v minus the integral of v du. Does that look familiar? Isn't that the problem that we're after? Kind of. But let's go ahead and finish this out. So I'm going to rewrite this as I did right here. And so now it's secant x tangent x minus the integral of secant cubed minus secant. Happy with that so far? So now it's secant of x tangent of x minus the integral of secant cubed plus, oh, sorry, I forgot dx, plus the integral of secant of x. And all this is equal to the integral of secant cubed. So what are we going to do? What's our next step? I guess we also have to think for a second, what are we doing again? Sometimes you have to pause for a second and say, wait, what am I doing again? What am I trying to do? We're trying to find the antiderivative of secant cubed, right? And this is the problem that popped up. So I'm going to solve for this. So I have 2 integral of secant cubed equals secant of x tangent of x plus, now it's helpful if we know the antiderivative of secant is 1/2 natural log of secant of x plus tangent of x. Then we don't have to like derive that again. Oh wait, I'm sorry, it's not 1/2, it's just natural log. The 1/2 is coming next, sorry. I got one step ahead of myself. So the antiderivative of secant is natural log of secant plus tangent. So what happens when I solve for integral of secant cubed? What do I get? One half secant of x tangent of x plus 1/2 natural log of secant of x plus tangent of x. So now if I go over here, I'll just substitute what my answer is there, right here. Plus c. Now I could simplify that. Because you have secant tangent minus 1/2 secant tangent. So it's really 1/2 secant of x tangent of x plus 1/2. Whew. Is that difficult? Is that hard? Yeah, it is. It is. I'll admit it. That takes a lot of work and a lot of perseverance and a lot of dedication. Very doable, but you have to just have the mathematical grit to stick to it. Yeah.
So when you're distributing the negative, you wouldn't do a negative, like minus 1/2 natural log?
Oh, you're right here. Yes, you're right. So what should be fixed here? Thanks. Yeah, this should be a minus. Good catch. Very nice.
Should I star this? Will this ever show up again? Should I learn how to do it?
Should learn how to do it.
Yeah.
Could I give you integral of secant cubed as a question? Absolutely. Integral of secant cubed by itself it's not the hardest thing that you've ever done in your life. It's pretty clean, right? You know, everything is very crisp. There's no constants that you have to keep track of. It's a good example of the kind where you have to solve for the original problem. There's this trick right here where you have to say, oh, tangent squared is secant squared minus 1. I mean, that's a well-rounded problem in that it hits a lot of the different techniques all there. I mean, you could make it really nasty, or you could make it much nastier by making it secant cubed of 3x minus 1. Like, just think, you know, if it was this instead. Or put a 2 out in front of it. Now there's just so much more to keep track of, right? You got to keep track of that 2. You got to keep track of the 3x minus 1 with the u sub.
You wouldn't do that, right?
Not intentionally, probably.
Okay. But unintentional.
Yeah. Other ones that you want to work out?
99.
What's that one?
Cosine squared
Okay, Megan, I want you to think about that, though, in light of what we talked about 10 minutes ago. So cosine squared of 3x. So let's first do a u sub. And so we're there, right? And what's the antiderivative of cosine squared? It's 1/2 times x plus sine x cosine x. It depends on which form you're going to do it in. It's either 2 sine, it's either this or it's sine of 2x over 2. Right?
So it's still not over 2, like right now. It's just sine x cosine x.
One of them is over 2 and the other one's not. Which one's over 2? Everybody agree with that? You just did it 10 minutes ago. Did you just write it down? What's the antiderivative of sine squared?
Oh.
We did it. We said it 2 ways.
Which way do you want?
I don't care. But Colin wasn't sure if this should have been over 2 or it's Colin, right?
Yeah.
Oh, you looked at me like I was crazy for a second. Colin wasn't sure if that should be over 2 or not over 2. And how you memorize it, I don't care, but you should definitely know they're equivalent. And apparently I don't know that we're 100% on board that they're equivalent. We literally just did sine squared, and I told you cosine squared is the exact same except of the plus sign. So what was sine squared? Sine squared was this, right? But it was a minus right there. Sine squared was also this. But it was a minus right there. These two are equivalent because of that double angle identity. All right? It's up to you which one you go with, right? So, but that's not the answer to this problem, because what we really need to do is 1/3 times 1/2 u plus sine u cosine u, right? So that's going to be, oops, that's 1/3. That's going to be 1/6. What's u? 3x. So you could leave it like that. Now, if you use the double angle identity and you wrote it the other way, it's not going to be 2x, it'll be 6x. Because if you did it this way, so here's one answer. Let's put this in orange. If you looked at it the other way, using this idea, it's 1/3 times 1/2 u plus sine 2u over 2, right? But what was u? 3x. So that's 1/6 times 3x plus sine of 6x over 2. And maybe that's what's in the back of the book. Okay? This and that are equivalent. It's up to you. It's up to you. You have to decide which way you like it. How do we feel about that? Yeah. Yeah, any ever, are we okay on this? Are we freaking? Matt, you say 75?
Yeah.
What's that one? Tangent to the fifth of 2x secant squared of 2x. Whew. It's a lot easier than what I heard the first time. How about we just say u is tangent of 2x? What's du? Secant squared of 2x times 2 dx. So du over 2 equals secant squared of 2x dx. So 1/2 u to the fifth du. Or 1/2 times u to the 6 over 6. Or u to the 6 over 12. Or tangent to the 6 of 2x over 12. Let's see. That one was easier than you probably made it out to be. And that's what happens, guys. Sometimes you get caught up in these and you're cranking through these and they're difficult and you're like, then there's an easy one standing right there, and they're looking at you and you're like, oh crap, I don't know how to do this. This is difficult. I'm not lying. This is tough stuff. It is, you have to work hard at this. Some people will say that the test over this, when we take the test over the techniques of integration, and this would be true of any Calc2 class, but the test over techniques of integration is the hardest test in all of your calculus classes. Because you have so much to keep track of, you have all of these different weapons in your arsenal that you have to attack different problems at. And you could start working on something and spend a bunch of time and then realize, oh shoot, that wasn't the right way to do this. And you're like, oh, I wasted all that time. But the only way that you can kind of avoid that is just like keeping up and practicing. Which I think a lot of you are doing. I'm not saying you're not. I'm acknowledging that most of you are working with us. You want to do another one? I got time. Yeah.
How about 100 more?
What is it?
The integral of sine squared of x dx plus the integral of cosine squared of x dx.
The answer is x. Well, how did I do that so fast? That was my favorite one out of all of them. I remember that. That was a last minute add-on. When I was picking the problems for you to do, I saw that and I was like, oh, I love it. Did you guys hear that problem? The integral of sine squared plus the integral of cosine squared. You can actually undo what was done and rewrite these as one integral. Because the integral of a sum is the sum of the integrals and vice versa. So what's the integral of sine squared plus cosine squared? Well, sine squared plus cosine squared is 1 dx. So slick.
Since we memorized, what the antiderivative of time.
You could have just substituted them in, and if you simplified it, you're gonna get x.
Okay, cool.
You'll get actually 1/2 x plus 1/2 x. That's what you'll get. How about that? Should we take another quiz on this tomorrow? I think so. Yeah, I'm not gonna give you any more problems to do tonight. I think we need to. Yeah.
With the, like, the.
Or trig subbies, or trig powers, I mean.
Like this. Oh. Oh my god. Are you joking?
It'll be quick, it'll only be like 2 problems. It's not gonna be, it's not gonna be as heavily weighted as others.
That's the word. Get one wrong, you get to do the math.
Yeah, but if it's not worth as much as the other one. What? Oh, I don't know if Delta Mac has powers and trigs or not. If it does, I will, yeah. I worry that those might be too hard. I'm gonna give you the easy. Oh, talk, okay, so you're gonna do this what day? Tomorrow and.
Just right up there.
What's that? You mean 4-5?
Yeah, I think
So
so.
you have a period 4-5, when do you have lunch?
And then I think,
Okay, so you'll come at 6 lunch, okay.
yeah.
Yep, that'll work.
And then,
That quiz, you still gotta make up that quiz from last week.
maybe could I just do both? Maybe like if I have enough time after the.
Yeah, I'm more concerned about the exam.
Yeah, me too.
Quiz I can worry about.
Anytime. All right, I'm good.
Oh, wait, I need to sanitize. Don't sit down yet.
Did you shred it?
I haven't yet, I'm gonna do it here in a second, hold on. Do you want to spray them?
Me?
Yeah.
Ooh. Yeah, you did a lot. Maybe like a third of what you did. Sorry. Yeah, shoot.
How'd it work out, Gary? Are you
I
enjoying
did a
it?
lot, but they're really clean. They're super clean.
It smells clean in here.
Well, you should do that to my physics room. It smells like booty in there.
Smells like what?
It smells like booty. It's awful.
Booty.
Yeah. It's bad. Not bueno.
Let's see if Snyder wants this.
I want that.
You don't even know what it is.
It's a donut.
No, it's not.
Cookie.
It's a smoked salmon bagel.
Is it really? Yeah, I don't want that.
It's so good. You never had smoked salmon?
Sounds good.
You're shaking yourself. You can do it bright pink. That'd be good.
Or like, blue. Oh, yeah. I think the one time we'll be able to work it out. Yeah. Yes, 2 windows open space. This isn't even one.
I can see the heat.
You gotta let that fall out.
Get the window open. So, close the window. Yeah, let's do that a little. Just like that real
We shut the
Yeah,
windows.
Mr. Mitter?
I'll do it for you. Yeah, go do it.
Yeah, you should.
Just a little. You can make it like crack, but like not that open.
You should close one of them. You don't want by the doors.
Just go.
That did absolutely nothing.
Maybe that. Like come in and be like, what are you doing? I think it's
Not a lot.
Oh, wait, I feel like it's really hard. Can we shut the
I've used it 3 times.
Here.
4 times.
4 times ever.
Watch.
I mean, I've only had it for like a month and a half.
Oh, you got a new one, right?
Yeah. I smoked some salmon yesterday. He's got,
Never bring that.
he has a bagel right now.
Okay.
A bagel with some cream cheese and smoked salmon. Have you ever had that?
That sounds so good.
It's delicious. It's delicioso.
I'm so proud of you.
It's good.
You're so proud of me?
No, of me.
Oh.
I don't know why.
Why? Why are you proud of me?
I just said I had a bagel for
I'm
breakfast.
proud of you.
Thank you. For what?
Nicole, I have to confess something to you.
Oh.
I didn't know who you were when you said hi to me when I talked to you at lunch.
Oh, yeah, you looked confused and I was like, oh.
Like, you were sitting down and, like, I didn't really get a good, like, straight-on look at you. And I'm like, I don't want to ask this girl who she is.
It was the most awkward.
And so then I texted Miss Miller. I was like, who's that thing? I was like, she's like, Nicole Bryan. I'm like, oh my God.
Did you finish the thing? It's not done yet, but hopefully by the end of this week. Yes.
So, in general, these were pretty good overall. In fact, I think last period, I mean, I would say they did better on that than you guys did this time. If anybody wants to see this key, I'll Which one do you want to work out? Number 3?
Yeah, 3.
So 3 is this. It's the natural log of x squared, which is not the same thing as, oh, you haven't taken this. Yeah, why don't you do that right now? Just pull one of those desks out in the hall, will you? Make sure it's like that. And then Aaron, me, will you shut that door when he leaves? So are you guys going to shave your heads?
No, you're shaving your head.
I
You
am.
make it to state. We are bleaching our hair though.
If we make it to state.
If we make it to state, you're.
If anybody makes it to state,
Yeah, you have to shave your head.
I would shave my head.
Well, how about this? Would you dye your hair like fun color, like neon green or like neon
If
pink?
anybody made it to state, I would do that.
You would? All right. Like girls team or guys team?
Yeah.
Okay. I'll let everyone know at practice. But the guy relays are bleaching our hair.
Did you bleach your hair?
Round 2.
Yeah. So, I mean, we have 3 girls that are qualified individually, 3 relays, and 2
Isn't
boys.
your daughter qualified?
Yeah, she really swam well on Saturday. Best I've ever seen her swim well. Like, yeah. I don't know. What are we doing? Oh, this problem. So just for fun, I'm going to do it this way, because I did it the other way last period. You can actually I was going to say, we got to be careful. That's not natural log of x squared. That's natural log of x all squared. There's a difference, yeah? Last period, when I set this up and I did it, I just let u equal that and dv equal dx. But you can also do it this way. I'm going to do it that way just for funsies. So du is 1 over x. And then v, you got to actually know the antiderivative of natural log of x. So it's the natural log. No, it's not. It's x, natural log of x minus x. So now I do u times v minus the integral of v du. So that's natural log of x times x natural log of x minus x plus natural log of x when I distribute that minus 1. So that's natural log of x, x natural log of x minus x plus the antiderivative of natural log of x, x natural log of x minus x, antiderivative of 1 minus x. What? How did it become a plus sign? It was a shouldn't have. Should have been a minus sign. And actually, Billiam, that should all be in parentheses because that minus and that minus should hook up and make it plus. Okay. Other questions? 4? What's 4?
The integral from 0 to 1 x times e to 2x dx.
So I'm doing this using Rapido. What? Yeah, no, I feel the heat. It's making me boil up here. So x e to the 2x over 2, right? Minus e to the 2x over 4. Then evaluate that from 0 to 1. Now, some of us had some trouble evaluating here. So it's going to be 1 e squared over 2 minus e squared over 4 minus 0 over 2 minus e to the 0 over 4. E to the 0 is 1, friends. So this ends up being e squared over 2 minus e squared over 4 minus plus 1/4. And then if you want to simplify e squared over 2 minus e squared over 4, it's e squared over 4. Because 1/4, or 1/2 minus 1/4 is. Okay. Right. Oh, and Gavin.
Yeah.
Who took the picture? You guys. And can you put district bound? You guys are seeing from the
Colin. What?
Fortunately, you didn't post that in there. But taking a picture inside of a bathroom is like one of the worst things that you can do in swimming. 2 years ago, when I was at the state meet with Emmy, meet's going on. This is when Hip was the head coach at Centerville. All of a sudden, in the middle of the meet, there's an announcement of the PA. Would the Centerville head coach please report to such and such location? Hip goes in there, and the Canton police are in this room, and the entire head of OHSAA and the Canton police are in this room, and they said, we need this girl, such and such girl. We need her right now. And it's like, okay, so they went and found her. This is a girl on Centerville's team. It's like a freshman or a sophomore. She had just like innocently taken a video of some boys who accidentally walked down the pathway to the girls' locker room at the auditorium. And you didn't even necessarily know it was in the locker room. I mean, you only would know if you knew what the locker room looked like, because it was down this like kind of hallway. And then posted it and tagged OHSAA like state swim meet. And the police were there, like to hammer this girl. And then they realized, okay, well, this was an honest mistake. No one was naked. But this girl, I mean, in the middle of a meet, she walks into this room, and the police, are you so-and-so? She, just started sobbing. Taking pictures inside of a bathroom or inside of a locker room. Not a good idea. They were about to throw her out of the meet and disqualify her. So that's future reference. Don't take pictures inside the locker room. I was gonna use that picture for Twitter, but I was like, nope, I'm not doing that. It's a big no-no. because it looked, I mean, you can tell it was in, Colin sent it to Rachel yesterday, and you could tell that it was in a bathroom. Yeah, because there's like sinks there. So, it was a nice picture. And then the girls made one too.
Because they copied us.
Yeah. All right, so let's talk about your homework. Anybody got any questions? Yeah. Tell me what it is.
The integral of tangent square x equals x.
89 is the integral of what?
Tangent squared x. Secant x dx.
Oh. So this one's kind of nasty, I think. So what did you try, Samuel?
Like everything I know, I can figure out.
So you threw everything you had at it. Everything but the kitchen sink. Everything. There's some expression like that. So, you know, when I first look at this, I think, okay, well, what if I did this? What if I pulled one of those tangents over there and wrote that as tangent times secant squared? Sorry. Nope. It's not what you get. Let's try that again. It's tangent times tangent x secant of x. Which that's a, you know, it's a strategy. But the problem is I've got the wrong thing here. In order for this to work, this wouldn't need to have been secant squared. So then u would have been tangent. Okay? Another strategy might be to rewrite that tangent squared as secant squared of x minus 1 times secant of x. Like that. And then you end up getting secant cubed of x minus secant of x. But right now, we don't know the antiderivative of secant cubed, do we? Huh. What if we did this and we tried that by parts? What do we get? What if I said u is tangent of x and dv is secant of x tangent of x? So du is secant squared. V is secant of x. So if I do this by parts now, I have u times v, secant of x, tangent of x minus, oh crap. There's secant cubed again. So it appears that no matter what way we do this problem, we are going to be forced into integrating secant cubed. So let's just do it. Now what I'm going to do is I'm going to integrate secant cubed over off here to the side, just because I'm going to have more room to do it. And then I'll take what I get and then stick it over here. Or we'll stick it over here, either one. Okay? You guys see that this was two different ways. There's not an equal sign here. Like, I tried this first, and then I said, oh, that doesn't, well, we initially thought that didn't work. So then we tried this technique, and we got here. Okay, I mean, this is not going from, this is not flowing down, okay? All right, so let's do secant cubed off to the side and see what we get. So I think we'll have to do this like secant times secant squared. And I'll do this by parts. So if u is secant, du is secant tangent, and v is, if dv is secant squared, v is what? Tangent. So that's secant x tangent of x minus the integral of v du. And if you notice, that's actually the problem that we were trying to solve initially. Comes up in secant cubed. Okay? So I'm going to write that as secant of x times secant of x, secant squared of x minus 1. And then I'm going to do this as secant x tangent x minus secant cubed x minus secant of x. Okay, now at some point during this whole mess, you probably are going to want to pause and say, wait, what am I doing again? What is it that we're doing here?
Finding antiderivative of tangent squared x secant of x.
Well, that was initially. What am I doing right now, though?
Finding antiderivative of secant.
Right, I'm trying to find the antiderivative of secant cubed. Okay? So, do you see the antiderivative of secant cubed now within the problem? So, the antiderivative of secant cubed equals this, right? So, the integral of secant cubed is going to equal secant of x tangent of x minus the integral of secant cubed of x, and then minus plus the integral of secant of x. I split that up into two separates. So now I'm going to bring this to the other side and say, oh, that's 2 integral of secant cubed is secant of x tangent of x plus, what's the antiderivative of secant of x? Do we know that? We've done it before. We did it like the first or second day back in real life school. If you go back and look in your notes, we used a clever form of 1 to find that antiderivative. I'm just going to tell you for time's sake. It's the natural log of secant of x plus tangent. So now what do? What's my last step? Divide by 2. So the antiderivative of secant cubed of x dx is 1/2 secant of x tangent of x plus natural log of secant of x plus tangent of x. Okay? So this is what I'm going to substitute for right there. And now if I wanted to, I could actually simplify this. Secant tan minus 1/2 secant tan. If I distribute that 1/2, I'm going to get 1/2 secant tan minus 1/2 natural log of secant x plus tangent x. That was yummy. How do you like that? It's gross. Interesting. Guys, is this hard? It is hard. This is hard. I'm acknowledging that this is hard.
You have to work hard to get this. Like, work hard. If you ask students who have taken Calc 2 before, oftentimes they'll say Calc 2 is the hardest of the three. And more often than not, if you ask them what part of Calc 2 was the hardest, they're going to say this, the techniques of integration. That when you have a test over that, that's like the hardest test that you might take in the entire Calc sequence. Because there's so much that you have to keep track of, right? So many different techniques. And then sometimes you could start working on a problem and go nowhere and spend all that amount of time, you know? And you're like, oh my gosh, I just wasted all that time and I got nowhere. I went in circles. This is definitely hard, right? I acknowledge that this is hard. But I also have every bit of faith in you that you can do it. Yeah. Oh yeah, she forgot about Matthias out there. You think he's just sitting there? Well, I just didn't, I mean, what time is it? What time are we done? Oh, so you've been about there 20 minutes. It's up there. I mean, you're almost. You're about done. But yeah, come on in when you're ready. Thanks, Nicole. All right, you guys want to do another one? Which one? 78. What is it? Tangent squared, secant squared? That's one probably that when you see me do it, you're going to be like, oh my gosh. I made that a lot more challenging than it needed to be. Thaddeus, what'd you do with that quiz? Oh, okay. Just throw it on my desk. Tangent squared, secant squared, huh? Isn't the derivative of tangent secant squared? So this is just u sub. Oh, of course. It's easy to do. There's a similar one to this, like maybe it was tangent cubed of 2x times secant squared of 2x. Can't remember what number that was, but very similar problem. So easy to overthink.
I actually got the answer to that correct, but I circled it for some reason.
Oh.
I can't remember why. Maybe I thought I got it wrong.
Couldn't tell you, man. Other ones. Yeah. 90 what? Tell me what it is. It's just easier. Secant to the fourth? Is that what you said? Ooh, they didn't ask about this one last year. So, I think when we have an even power of secant sitting there by himself, okay, what you want to do is do that first, and then leave this guy alone, and then change the other one into something with tangent. Okay? So secant squared is 1 plus tangent squared. Okay? Now, this is going to be a u sub. U is tangent of x. What's du? Secant squared.
So this is 1 plus u squared du, which is u plus u cubed over 3 plus chips. So now go back. U is tangent of x. Tangent cubed x over 3 plus chips. Autre question. It's very satisfying when you do these and you get them right. And you see it. It's very, I mean, it's a lot like when you're proving trig identities. How many of you found that kind of secretly satisfying? Nicole, were you saying you found that secretly satisfying, or were you raising your hand for something else? Oh, both. Okay, what else are you raising your hand for? You got another one?
Yeah.
Lay it on me. Cosine squared of 3x. Okay. So the question is, do we remember the integral of sine squared? We did that in class the other day. Okay? The integral of sine squared, or the antiderivative of sine squared, depending on which way you do it, is 1/2 x minus sine x cosine x. That's one way of doing it. Or you get it, that's if you do it by parts. If you do it using the double angle identity, which I think that's how we might have done it both ways, you get this. But these are equivalent, friends. Okay? Those are equivalent. And I think we even showed why they were equivalent on Friday. Because sine of 2x is 2 sine x cosine x. So those 2's would cancel. Okay? Now it turns out, my friends, the antiderivative of cosine squared is the exact same thing, except one little difference. The antiderivative of cosine squared is this, but with a plus sign. Or that with a plus sign. And if you want to memorize those, you are more than welcome to do that. Okay?
It's still fine.
It's still sine, correct. So now that you know that, it makes this problem maybe a slightly easier because we don't have to go through all the work. You could just straight up u sub this. And say, oh, that's cosine squared of u du. Oh, I'll just use what I know. The antiderivative of cosine squared is 1/2 times u plus sine u cosine u. So that's going to be 1/2 3x plus sine 3x cosine 3x. Okay? However, if you look in the back of the book, I don't know that that's going to be the answer. Yeah. Oh, thank you. Thank you. Thank you. Forgot the du over 3. If you look up the answer in the back of the book, it might be this. 1/6, and then they're going to use this. So it would be u plus sine 2u over 2. So they would be 1/6 3x plus sine of 2u. That would be sine of 6x over 2. These two answers, boys and girls,
are equivalent. Okay? I'm not sure. Nicole, do you know which one's in the back? This one or this one? You don't know. That's okay. It's not that important. So you don't have to get your phone out. Unless you're dying to know your stuff. So if you want to memorize sine squared and cosine squared, knock yourself out. I probably would. Other question? Otra questiones. So we got all these? Rock and roll?
I don't know if I bought all of them, but I wanna like move on. Like the ones that I still don't have, because I feel like I can maybe do them now. So.
We're going to take a quiz on this tomorrow.
What?
Tomorrow, yeah. Just on these powers of trig. We're not going to have any more problems tonight. But this is the only way I can hold your feet to the fire, so to speak. So make sure you're staying on top of these. Yeah.
Okay, so, 101 is like the integral of sine squared of x dx plus the integral of cosine squared of x dx. Is that just adding back? So it'd be like 1/2 times x minus sine.
You could just add those two together, exactly. But I think there's an even quicker way. That's my favorite one of all of them. 101 says this. It's the integral of sine squared of x plus the integral of cosine squared of x. Well, you know that the integral of a sum is the sum of the integrals. So we can work backwards and say that this sum of two integrals is actually the same thing as this. And sine squared plus cosine squared is 1. And the antiderivative of 1 dx is x plus c. So if you did it the way that you were suggesting, Nicole, what you're going to end up is these two parts, this part and that part are going to cancel out, and you're going to end up with 1/2 x plus 1/2 x. Yeah. I mean, I would say, if it were me, I would know the Pythagorean identities and the double angle. And I would just know the double angles for sine and cosine. Now, I got mixed reviews last period when I asked if you guys learned the double angle identities last year. Some people said they did, some people said they didn't, which probably means that you did. I'm going to ask the Cridgester next period.
Probably at some point, but I don't remember off the top of my head.
Like sine of 2x is 2 sine x cosine x. Cosine of 2x is, well, it equals 3 different things. Cosine squared minus sine squared, 1 minus 2 sine squared, and 2 cosine squared minus 1. Carrie's looking at me like I have 2 heads. Now the question is if you did those during the shutdown, during the pandemic. Because if you did it then, you probably don't know.
We did do it.
that your notes from last year?
Yeah, I just put calculus in the back. There's no space.
Oh, it's just like one big math journal. Interesting. Other questions? I could do these all day. But you're the ones that need to know how to do them.
Can we do one?
I already know how to do them. What?
Do one of
What's that?
the, is the integral from 0 to 2 pi of x sine 2x.
Ooh, baby. Okay. The integral from 0 to pi or 2 pi? Of cosine.
Cosine of x sine of 2x.
Speaking of the double angle identities, I'm going to rewrite that as cosine of x times 2 sine of x cosine of x. And then that's going to end up being 2 integral from 0 to 2 pi of cosine of x squared times sine of x. Huh. So how are we going to do that? U. So u is cosine of x. What's du? Negative sine of x dx. So that's negative 2 integral of u squared du. Let's change the balance, shall we? Let's change the balance. When x is 0, what's u? What's the cosine of 0? 1. And when x is 2 pi, what's u? What's cosine of 2 pi? It's the same as the cosine of 0. Oh! What's the answer to this? The integral from 1 to 1. 0. We don't even have to do it. Now, if you wanted to think geometrically about this problem, and you wanted to interpret this original problem, maybe geometrically, if you graph that function, cosine of x times sine of 2x, and you looked at that function between 0 and 2 pi, you're going to have an equal amount of area above the x-axis as below the x-axis. That's why that would come out to be 0. Yeah.
Is there the kind of or like cosine and sine in any like way?
Is it always going to be 0?
Yeah.
That's a really interesting question.
Like
if you have 0 to 2 pi of any combinations of sines and cosines, will it always be 0? What if it was integral of sine squared? Would that be 0? The integral of, would this equal 0 if I had said the integral from 0 to 2 pi of sine squared? Would that equal 0? I think you could look at that and tell me that can't be 0. Why can that not equal 0?
the y would never be less than 0.
Right. Sine squared is always positive. So if you're integrating sine squared, you're adding up all those y values between 0 and 2 pi. You're adding up positive y values. You're never going to go negative. That makes sense? So there's one counterexample to your question.
I wonder if it would always be 0 if you didn't have any.
Interesting question. Cosine of x times sine of 32x?
Yeah.
That's going to be just like that. Well, is that going to be just like that? Why don't you try this on when you go home tonight? Do sine, graph cosine of x times sine of ax in decimals, and let a be a slider. And change the values of a and see what happens to the graph. Hey, I'll see you tomorrow. What? Yeah. Because I actually don't, off the top of my head, know the answer to that, Samuel. I have to think about it. There are some of those that I do know the answer to, but some I don't.
Are we gonna meet for Friday? And
Not so much.
what about part 3?
Not so much. I mean, we do a lot of proof thinking, but not formal proof, right? Better. Oh, yeah? He's with HIP, he should have been with HIP last period. No, he eats in HIP stream because he has fourth lunch. Well, he's already gone. His fourth lunch is passed. No idea. Okay, bye.
Okay, Dad, in social studies, I was, or in history, I was going through all the other, actually not Euclid.
Talk to me, Goose.
I'm going to have Collins here. Yeah.
Speaking of Oliver Coates.
Oh my God.
Is that why is that why that didn't work out for you?
Sarah is not back one. What do you actually do at practice?
Sit over at the front and just kind of chuck a chunk of metal every couple like 10 minutes.
You good?
Okay. Oh shoot. It's great. We barely run. Rowing.
You get hurt.
Rowing.
2 years ago.
What? No.
Oh, that was
Oh, no, we were just talking about track.
I was literally.
Joe said you find it fun. I'm like, well, I don't run.
Are you gonna do this year?
I might go to some of the long distance practices and not
I
run
literally think
still.
I would like. I love dry lands.
Rowing's fun.
They're so fun.
That's all rowing. All we do
I
is
love
rip
rowing.
and like not run.
Not
That's
wrong.
all the rowing do.
I have to run before I lift every day.
Why?
I don't really know. But it's part of the program, so you know. Get your heart rate up.
It's just a, get joyful.
Just for like.
Well, probably. I mean, getting your blood flowing in your muscles is a good thing for you.
I don't understand people who just walk in the gym, throw their crap down and start lifting weights. I cannot do that.
That's what I do.
Really?
Yeah.
I can't.
It's just because I'm lazy.
No, I need to get in the zone first.
They had jump ropes, I would do that, but I don't think they do it.
I don't want you to dry land if you're coaching you.
You've done that.
You've done that all the time.
You know,
It's
nice.
in here.
Yeah.
During social studies, I was bored. I got scored our test, and they were going over.
We jump up on deck.
everybody else.
We
Oh,
jump
so
up
what?
we jump up for like.
I think
If I
Well,
lived
so we
in
used to,
Central
it used to be like, do
or
200 reps, like that's what Sam would say.
Southeast
And
Ohio,
kids,
I
like,
would rank
I love
11.
I like.
If we were in the Northeast, I'd be
Dude, make
ranked
us do
5th.
competitions and
And if we were in the
Oh.
Northwest, I'd be ranked
Wait,
6th.
what? No, the loser for us just went to burpees.
Because I
And
can't
I would choose somebody that could not jump rope for their life.
People like you there.
Not at all.
That's smart.
Yeah, it's hard.
Guys,
Wait,
smart.
Yeah.
So
What?
like, anyway, I don't think I understood.
So,
Crazy. Don't look at
So-
you
We
too.
had like a half.
What?
Run.
Okay, it was either
Wow,
burpees
what
or like 2 laps around the,
Yeah, he would do that when he was feeling nice.
because they're all sugar cookies.
Yeah.
So y'all can take it.
And then like winners would go against winners, so you'd be stuck, and the person would beat you by like 40, and then you'd have to go run again.
So wait, what's the competition?
It was like go to jump rope